Well, over the past years we have already published a number of tutorial videos about rotation axis machining. They're all visible on our website and also on the, let me see the website here, yes, and also on our YouTube channel. All these videos were about continuous rotation, so rotary machining where the part rotates while machining. However, there is a second method to use the fourth axis on your machine. You can use index machining. So use a simple 3-axis toolpath from one side, then rotate the part, again 3-axis toolpath, etc. We've made two simple animations to show you the difference. Here they are. Let me start one. This is about rotary machining, a very simple object like that you can see when viewed along the rotation axis. You see this box. This is the toolpath. It doesn't look entirely logical perhaps, but when you see the cutter move along the part, you see that the toolpaths are correct for the center of the tool. However, as you can see here, for the inside of this particular part, the situation is different. Dasproto simply cannot reach all parts of this geometry, and so much material will remain uncut. That's an undercut area. So the simulation shows a result that is completely different from the part that we wanted to machine. Rotary machining comes with its own type of undercuts. For instance, when I have this teacup, when I rotate that, it will be clear that the inside of the handle is an undercut. The cutter simply cannot reach that area when the cutter remains positioned above the rotation axis. A second example, a human figure. The area, this model has been machined from two sides, but when rotary machining, the cutter will not be able to reach the space between the arm and the body. So the second option is to use index machining. So we have a second tutorial video where okay, index machining. It's the same geometry, but now here is side 1. The cutter will redirect to a safe height to allow rotation. Side 2, and now for side 3 you can clearly see the difference. The cutter now can machine the complete inside of this particular geometry. So the simulation will show a part that is similar to the part that we designed in the STL file. Well, why do not we always use index machining when it's so much better? Well, it's not always better. It comes with a few important disadvantages as well. First of all, the toolpath for the several sides will overlap, which makes this a much less efficient way of machining a geometry. And also important, perhaps even more important, that it's for index machining, it's very, very important, I can't stress that enough, that the workpiece 0 point of the machine needs to be exactly with the tip of the cutter on the rotation axis. Any small deviation here will leave clearly visible marks on the resulting part. I will come back on that later. So for many geometries, here for instance this Abe Lincoln or any human head, this last simple continuous rotation gives optimum results. It's also possible to combine both methods. This has been done using rotation axis. Below the chin was an undercut, and we used index machining to remove the material over there. Okay, continue. Now the actual tutorial video that I was talking about. We are going to machine a corbel. This is a corbel. It's some part protruding from the wall to support a ceiling or a beam to support anything, nicely decorated in most cases. We downloaded this CORBL from 3axis.co. It was a free download STL file. And I want to machine that in black. Here we are in walnut wood. I got a nice beam of walnut, and I created some small blocks as my milling machine is small, so I needed a block to start with. Okay, so I have the STL file on my desktop. I have the wood, the size of my wood. I can start Deskproto. So here we are at my desktop. I've made it empty except for the Deskproto link and the STL file. So let me start Deskproto. As you can see, here, there's a dealer edition, so I have to select which edition to use. I want to use the multi-axis edition, as obviously for index machining we need a rotation axis. I want to start the wizard, and the wizard that we need is 2 or more sides automatic rotation. First, check if the correct machine has been selected. Well, that's okay. In most cases that's your default machine, so I can advance and start this wizard. And as always, the first thing to do is load the CAD data. It's on the desktop file. It's a Gothic CORBL.stl. So we load it. Here we are. This is the CORBL with nice acanthus leaves. And we want to prepare it further. Well, I have a very small machine, so I can only make a very small CORBL. The width of my block of wood is 60 millimeters, so I put this the scaling option to dimensions, and I enter a width of 59 millimeters to nicely fall within my block, and the other axes are scaled proportionally as uniform is checked here. As you can see, the block is not correctly aligned with the rotation axis. 90-degree rotation around Z is needed. Well, I can enter that here, 90 degrees. I put apply, and here we are. On the left side is my rotary table, so here's the largest connection with the part. Further important is the number of sides. I need 4 sides for this part, from top, front, left and bottom, 4 sides. So I can say next, and here material and support, I can define the material support blocks, 0 point, machining depth. So let's do those one by one. My block is a bit larger than the bounding box. You see it's already a rectangular block here, but this is the bounding box of the geometry and the supports. My block is a bit larger. It's 150 millimeters long. It's, as said, 6 millimeters wide, and it's 35 millimeters in height. Okay, default support tabs. Well, on the left side I don't want a support tab. I want the block to remain present here, to have my part as stable as possible, with as much stability as possible connected to my rotary table. So I change the support tabs to custom, and I switch off the left tab. Okay, here we are, and the right tab, I need to edit that because now it's centered exactly on the rotation axis, but it needs to be attached on the extreme part of the geometry. So I can enter into the detail settings of the support block and move it down a bit. So let me say I will want to make it a bit larger as well, the cylinder, because some stability is needed here. So I want to make it 60 millimeters diameter, which is 8 millimeters in all directions, here from -17 to -1. Yes, and I also want to make it a bit shorter, something like this here. That will be okay. Yes, and we see that the support block has been changed, and now I trust it will give sufficient stability also when the material here has been removed, that I can continue finishing in the machining process. Okay, the part, the dimensions, the support tabs. Workpiece 0 point here is on the rotation axis with at the left side of the block. You can see it here, the blue cube gives the location of the workpiece 0 point. The milling depth is an issue, I need to change that. As you can see here, the default depth is half of the block, but for this side it needs to be much deeper. My block is almost complete depth I need. My block is 35 millimeters high, so I want to, for this side I want to have a depth of 33 millimeters, sorry. And the other two sides, well, they don't need to be machined very deep. A few millimeters is okay to have the relief machined here, so when I have a depth of 5 millimeters there, it is okay. Yes, so when I now press next, you will see that no, that's not true. That will be later. I was too soon. The other parts cannot yet be created as I need to enter details for roughing and finishing first. Okay, I want to do that. Roughing, I want to rough with a ball nose cutter of 6 millimeters. As said, this will be a small corbel as we have a small machine. I will leave all settings on default except for the spindle speed. It may be a bit higher here. Depending on the defaults that you've set for your machine, the values will be different here. So for you they may be correct already. That's roughing. And finishing, I want to do finishing with a bit smaller cutter. 3 millimeter ball nose. Here we are, 3 millimeter. Also here a bit higher spindle speed. The smaller the cutter, the higher the spindle speed. And the feeder rate may be a bit higher as well for finishing. So that's okay. And when I now press next, I want to quick a moment ago now, as you can see, Desproto will create the parts for all sides. Yes, that's essentially is a trick that Desproto used, because here there are 4 parts. However, obviously we want to machine one part only. We want to machine it from 4 sides. However, the trick that Desproto uses is to create one part for each side. Now let me show the toolpath. And I do not want to yet to write the N3 program file, as we need to fine-tune the settings a bit before we can continue. So here we are, this is side 1, this is side 2, we have side 3, the bottom, and here we have side 4. And well, I was explaining about the 4 sides, how this works. Normally, Desproto, when you save an NC program file, you save it for only that one part. But now we want to combine NC files for several parts in one combined NC file. Well, Desproto has a feature that enables that, and it's called chaining. When we open the parameters and we go to tab chaining, we see that one chain has been made in which all 8 operations are combined. So after roughing side 1, the toolpath for roughing side 2 will follow, side 3, etc. All combined in one large NC file. Or in fact, on my machine, as it doesn't have an automatic tool changer, the result will 2 different NC files, one for the large for the 6 millimeter ball nose cutter and one for the 3 millimeter ball nose cutter. That's about the chaining, that operations are combined, the toolpaths are combined. Then I also want to show you the trick that Desproto uses to give a rotation command in between here and here. Obviously a 90-degree rotation command has to be entered. That is done in the operation start end commands. Here we are, start end commands on the advanced step page, you see that first the z-axis move up to some safety distance, high enough that the cutter won't touch the block of wood while it's rotating, and for the first operation it moves to 0 degrees. And when we do the same for side 2, you'll see advanced start end that now it moves to 90 degrees. So in the NC file those commands are entered in between the toolpath for side 1 and side 2. First move up the z-axis, then rotate the a-axis. So that's okay. That's the explanation for part side 1 to side 4. Side 3 in this case is a special case. So let me switch off the toolpath. Here, switch off, and as you can see, the SCL file definition of this part is hollow. So we don't want side 3 to be machined at all, as then the result will be a hollow part with a side thickness of 0. So I want to remove the complete part for side 3 and then manually machine this side, make it flat when that's needed, or I can simply use the backside of my block for that side. So for side 3 I simply say remove, and Deskploto will automatically correct the chain. That one valid chain will be the result. Well, 2 more things that can be deleted. Here for side 2 and side 3 you also see roughing and finishing. However, the machining depth is only 5 millimeters, and for this geometry most of the material already has been removed while roughing side 1. So in fact for side 2 and side 4, which is now in fact side 3, the roughing operations can be deleted. That's to say, for this geometry. When you are machining a different geometry, the situation can of course be different. So I will remove this operation, yes, and I will remove this operation, yes. Okay, that's been done, and let me think what I need to do again. What I need to do next. And that is 2 more details I want to change. For roughing, I want to change the roughing side 1 the toolpath direction, as for machining wood cutting direction conventional is advised, so I want to make that conventional. And then for the finishing, as you see here, finishing also will machine this complete side surface. You see the toolpath here, the cutter goes very deep, and it is not really needed as this side will be machined anyway when machining side 2. So for finishing I will change the options for the ambient skipping. Now only the horizontal ambient area is skipped, as you can see here in the image. And I want to also skip the vertical ambient area, and you will see the difference. Now the toolpath down here have been removed, and well, this will give a better result anyway. So that's all for this project. I can save the project. I will simply call it test for now, and I will also save the toolpath files. This is here, write and see toolpath file. It warns me that the cutter may go below the bottom of the block, which is okay for now. I also call it test, and it will now ask, do you want to calculate the visible operations only, because roughing is invisible. No, that's not correct. I want to calculate or I want to save the toolpath for all operations, so not only the visible operations, and then it detects that a chain is present with those 4 operations, as we've reduced it to only 4 operations. And yes, I want to machine the complete chain, and now it will create 2 NC files, as I can show you here. See the roughing and finishing, and don't mind the icon, because the .iso files in this case full have been claimed by a different program, but these are NC program files that can be sent to my milling machine. So here we are, the Desproto part has been ended. Now I can still show you, which is interesting, perhaps a simulation of this side. I haven't yet done so, forgot to do so. So here is a roughing, here we are, and when I also do finishing, here we are. One more remark: when you see toolpath on this side of the block, this side of the block has been completely removed and machined off all material here, so the part will no longer be connected to your milling machine, to the rotation table of your milling machine. Then you will have used an older version of Desproto, because that is an improvement that we made while preparing this tutorial video. As you can see here in the about box, we are now at revision 10,444. So when you have an older version of Desproto 7.1, please download the bug fix version and install that, or you have to manually correct the area to be machined, as in the previous Desproto versions that area was larger. Okay, that's the Desproto part. I will close Desproto and we will continue to the milling machine. Before we proceed to the machine and start machining the block, I have one more animation to show why a very accurate 0 point is important for index machining. I promised I would come back on that. Here is the animation. This is what happens when the 0 point, the red 0 point, is not exact as it should be, the blue 0 point. So all toolpaths are shifted a bit, which for the second side, as you can clearly see, leaves a very visible ridge all over the part. So setting the 0 point is of utmost importance. Also, the rotation axis needs to be perfectly aligned with the x-axis or with the y-axis, if that's on your machine, the configuration. For continuous rotation, such error is much less important, as a small error absolutely will not be visible in the results. Perhaps the geometry is a bit different, but you can't see it. It will still look like a perfect model. However, for index machining, the results will be worthless because of all the ridges. Okay, now on the machine, I've very accurately set the 0 point. And here's the result. I manually machined this side to remove it from the rest of the block. I manually removed the support block that was present here. So this is machined, finished at side 1, side 2. This side also has been machined manually, and here is that last side. Well, a great result in my view. This is still a relatively simple geometry. Here's an example. You can also use much wilder geometries using with indexed machining. So I'm happy with this result. I hope you can also achieve nice parts, nice results using indexed machining.